Now, in this lecture, we will find out the value of line segment X. In the drawing, we have triangle ABC. We know that side AB is equal to side AE. We also know that line segment BD equals to 3 units, line segment DE equals to 7 units. And we want to find out the value of line segment EC that is equal to X. The value of this line segment EC that is equal to X. And we also know that angle BAC, this angle is a right angle, it equals to 90 degrees. Angle BD, angle BAD, this angle equals to theta. And also angle EAC, this angle is also equal to theta. And we want to find out the value of line segment EC that equals to X. Okay, so first of all, we will define angle DAE, this angle as alpha. That is to say, this angle is equal to alpha according to our definition. And from point A, we will draw perpendicular to BC. So we will define the touching point of the perpendicular from point A to BC as M. So this angle is equal to 90 degrees, and this angle is also equal to 90 degrees. And in the next step, we'll calculate the area of triangle ABD, this triangle, and we divide this area of triangle ABD with the area of triangle ADE. So we find out the ratio between the area of triangle ABD over the area of triangle ADE. So the area of triangle ABD, here the squared brackets is the sign for the area. It means the area of triangle ABD over the area of triangle AED. So what is the area of triangle ABD? The area of triangle ABD will be equal to the base of the triangle. We will take side BD as the base, so it is the base BD of triangle ABD times the height to the base. The height must create 90 degrees with the base BD, and you can see from the drawing that line segment AM indeed creates 90 degrees with the base BD. So the height is AM, BD is the base, the height is AM, that is the height to the base. The height creates 90 degrees with the base BD, you can see it here, all divided by 2. Over the area of triangle AED. What is the area of triangle AED? The area of triangle AED will be equal to the base of the triangle. We take side DE as the base, so it is DE times the height to the base. The height must create 90 degrees with the base DE, so and you see that AM creates 90 degrees with the base DE, therefore the height is AM. Over 2, so the base that is DE times the height of the base that is AM over 2 is the area of triangle AED. Okay. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And what is left from this expression after we cancel 2? What is left? It is actually BD times AM over DE times AM. So here we have AM in the numerator and AM in the denominator, so AM will get cancelled. And we know that BD is equal to 3 units and DE equals to 7 units. So in conclusion, we found out that the area of triangle ABD over the area of triangle AED is equal to 3 over 7. In the next step, we calculate the area of triangles ABD and the area of triangle AED in a different way. Here, the area of triangle ADE will be equal to the base. We take the base as AB. That is actually equals to the base that is AB. And the height to the base AB will be actually the height to the base must create 90 degrees with the base. So from point D, we will draw perpendicular to AB. So this angle equals to 90 degrees, and this angle is also equals to 90 degrees. We'll define the touching point between the perpendicular from point D and AB as point O. So because of the fact that line segment DO creates 90 degrees with the base AB, the height to the base is indeed DO. We define DO as edge 1. So the height to the base will be equal to edge 1 over 2. So again, the area of triangle ABD will be calculated in a second way. Is the base AB times the height to the base that is edge 1 over 2 over the area of triangle AED. What is the area of triangle AED? The area of triangle AED. Here we take the base of triangle AED as AE. So the base of the triangle is AE. So it is AE, that is the base, times the height to the base. From point D, we will draw perpendicular to the base AE, and it will be the height to the base. So here, so this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We define the touching point of the perpendicular from point M and AE as point K. And because of the fact that MK is perpendicular to the base AE, therefore MK will be equal to the height to the base. So we define MK as H2, so the height to the base AE will be equal to AE. So here we can write down that the height is A2 of triangle AED, the height equals to H2. So the base is the AE times the height to the base is H2 or divided by 2. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. What is left after we cancel 2? What is left is actually AB times H1 over AE times H2. So we know that AB equals to AE is given us in the question, so AB over AE will be equal to 1, so it will get cancelled. And we left only with H1 over H2. So we find out the values of H1 and H2 and we put them inside this equation number 1. So what is the value of H1? The value of H1, if we focus on the right triangle, triangle AOD, then in the right triangle, triangle AOD, sinus theta will be equal to H1 over AD. Again, in the right triangle AOD, sinus theta will be equal to H1 over AD. But we've already found out that, so here we actually multiplied this equation by AD, and we get that H1 is equal to AD times sinus theta so here we write down that H1 equals to AD sinus theta. In the next step we'll find out the value of H2. So here we'll focus on the right triangle, triangle AKM. In the right triangle, triangle AKM, sinus alpha will be equal to H2 over AD. Sinus alpha equals to H2. Actually, the perpendicular should be from point D to AE. The perpendicular to the base AE should be from point D to AE. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And we'll define the touching point of the perpendicular from point D to AE as point K. So here sinus alpha, and we'll define dk as h2, which is the height to the base AE. So here in the right triangle, triangle ADK, sinus alpha will be equal to H2 over AD. So here we will multiply this equation by ID, and we'll get that H2 is equal to AD times sinus alpha. So here we can write down that H2 is equal to AD times sinus alpha. So in conclusion, we found out that according to equation number 1, 3 over 7 equals to, but before that we have AD in the numerator and AD in the denominator, so AD will get cancelled, and we left only if sinus theta over sinus alpha. So in conclusion, we found out that 3 over 7 equals to sinus theta over sinus alpha. So here we will first multiply equation number 1, and we will get that according to equation number 1, 3 times sinus alpha is equal to 7 times sinus theta, and what is the value of angle alpha? From the drawing you can see that angle BAC equals to theta plus alpha plus theta. That is to say, angle BAC is equal to 2 theta plus alpha from one side, but from the other side it is given us the question that angle BAC, this angle equals to 90 degrees. Here it is given us in the question. So from the other side, angle BAC equals to 90 degrees. So from this equation, 90 degrees equals to angle BAC equals to 2 theta plus alpha. We will derive that 90 degrees equals to 2 theta plus alpha. Here we'll subtract 2 theta from this equation and we'll get that angle alpha equals to 90 degrees minus 2 theta. Angle alpha equals to 90 degrees minus 2 theta. So we can substitute alpha in equation number 1 by 90 degrees minus 2 theta. So we'll do it now and we'll get that according to equation number 1, 3 times sinus alpha, and sinus alpha is actually equals to sinus 90 degrees minus 2 theta, and it equals to 7 times sinus theta. Equals to 3 times sinus theta. Here we have trigonometric identity that states that sinus 90 degrees minus x equals to cosine x. So according to this trigonometric identity, we will get that sinus 90 degrees minus 2 theta will be equal to cosine 2 theta. Sinus 90 degrees minus 2 theta equals to cosine 2 theta. So here we can substitute sinus 90 degrees, sinus 90 degrees minus 2 theta in equation number 1 by cosine 2 theta. We'll do it and we'll get that three times sinus 90 degrees minus 2 theta equals to cosine 2 theta. 3 times cosine 2 theta equals to 2 times sinus theta. And we have trigonometric identity for cosine 2 theta. The trigonometric identity for cosine 2 theta is that it equals to 1 minus 2 times sine square theta. So, and according to equation number 1, we found out that 3 times cosine 2 theta equals to 2 times, it is equals, we need to 7 times sinus theta. So here we substitute cosine 2 theta by 1 minus 2 times sinus square theta. We'll do it now, and we will get that three times cosine 2 theta is 3 times 1 minus 2 sine square theta, and it equals to 7 times sinus theta. Here we will open the brackets on this side of equation number 1, and we will get that according to equation number 1, 3 times 1 is 3, and 3 times minus 2 times sinus square theta will be equal to minus 6 times sinus square theta. That equals to 7 times sinus theta. So here we will add to equation number 1 6 times sinus square theta, and we will also subtract 3 from equation number 1, and we will get that according to equation number 1, 6 times sinus square theta plus 7 times sinus theta minus 3 equals to 0. Actually, here we have a quadratic equation, and the general formula for quadratic equation is that ax squared plus bx plus c equals to 0. Here in this formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times a times c over 2 times a. And in our specific quadratic equation, the variable that we are looking for is sinus theta, so x equals to sinus theta. The coefficient a equals to 6 units. The coefficient b equals to 7 units. And c equals to minus 3. So we put the data inside the formula for x, and we will find out the value of sinus theta. The value of the values of sinus theta, because it might have more than one solution. So x equals to sinus theta, so sinus theta will be equal to minus b equals to 7, so minus b will be equal to minus 7, plus minus square root of b squared. B equals to 7, so b squared will be equal to 7 squared, that is 49, minus 4 times a is 6, so it is minus 4 times 6, times c is minus 3, so it is minus times minus 3, all divided by 2a, and a equals to 6, so it is 2 times 6. So in conclusion, we found out that sinus theta equals to minus 7 plus minus square root of 49 minus 4 times 6 is minus 24, minus 24 times minus 3 is 72. So inside the root we have 49 plus 72, all divided by 2a, that is 2 times 6, that is 12. So in conclusion, we found out that sinus theta is equal to minus 7 okay, so sinus theta equals to minus 7 plus minus, and the square root of here 49 plus 72 is 121 over 12. So, and the square root of 121 is 11, so I will write it down, and sinus theta will have two solutions that are possible. So sinus theta will be equal to minus 7 plus minus, the square root of 121 is 11 over 12. So, as I already said, sinus theta will have two solutions that are possible. The first solution is that sinus theta is equal to minus 7 minus 11 over 12, and the second solution that are possible for sinus theta is that sinus theta is equal to minus 7 plus 11 over 12. So we start with the first solution. Here sinus theta equals to minus 7 minus 11 is minus 18. Over 12, and minus 18 over 12 is minus 1.5. So we found out that sinus theta equals to minus 1.5. But because of the fact that the function sinus theta, the function sinus, can accept values that are between minus 1 and 1, sinus theta can receive values that are greater or equal to -1 and that are smaller or equal to 1 plus 1, and because of the fact that minus 1.5 is less than -1, is smaller than -1, it means that the answer, the solution that sinus theta equals to -1.5 is the incorrect answer, because sinus theta can never receive the value of -1.5 because it exceeds from the range of values that it can accept. The only value that it accepts, that it can accept, the function can accept, is ranging from -1 to +1. And because of the fact that -1.5 is less than -1, therefore this solution is incorrect solution, because sinus theta can never receive -1.5 because it exceeds the range of values that it can receive, that it can accept. Therefore we will cancel this solution, and the only solution that is left is that sinus theta equals to -7 plus 11 over 12. -7 plus 11 is 4, and 4 over 12. We'll divide both the numerator and the denominator by 4. 4 over 4 is 1. 12 over 4 is 3. So in conclusion, we found out that sinus theta is equal to 1 over 3. Okay, sinus theta equals to 1 over 3. So in the next step, we'll focus on triangle ABE. This triangle ABE. Triangle ABE is an isosceles triangle. Why? Because it has two sides that are equal to each other. That is to say, AB equals to AE according to what is given us in the question. Therefore, triangle ABE is an isosceles triangle. So I will copy the isosceles triangle ABE in a new page, and we will analyze triangle ABE. I repeat again, triangle ABE is an isosceles triangle because of the fact that AB equals to AE. AB equals to AE. I write it down. Triangle ABE is an isosceles triangle because of the fact that AB is equal to AE. And the base of the isosceles triangle, triangle ABE, is BE. I'll write it down. BE is the base of the isosceles triangle ABE. So the base is BE and AM is the height to the base BE. Why? Because of the fact that line segment BE creates 90 degrees, line segment AM creates 90 degrees with the base BE, therefore AM is defined as the height to the base BE. Repeat again, AM is the height to the base BE. AM is the height to the base BE. Line segment AM is the height to the base BE. And we have rule number 1. According to rule number 1, the height to the base of an isosceles triangle bisect the base. Bisect the base. I will repeat on rule number 1 again. According to rule number 1, the height to the base of an isosceles triangle bisects the base. So here, according to rule number 1, the height AM to the base BE bisects the base BE. That is to say, BM equals to ME according to rule number 1. We will conclude from rule number 1 that BM is equal to ME. Why? Because the height AM bisects the base BE. That is to say, divide this to two equal parts. That is to say, BM equals to ME. According to rule number 1. So if we define BM as Y, BM equals to Y, according to our definition, so we can write down that BM equals to Y. From this equation, Y equals to BM equals to ME, we'll conclude that ME is also equals to Y. ME equals to Y. I'll write it down. So we actually found out that BM is equal to Y and ME is also equal to Y. So what is the value of BE? You can see it from the drawing that the value of side BE is equal to BM plus ME. BM plus ME. Okay, the value of side BE equals to BM plus ME, but BM equals to Y. And ME is also equals to Y, so it is Y plus Y, and Y plus Y is 2Y. So from one side, BE is equal to 2Y, but from the other side, BE from the other side, here BE equals to BD plus DE. Okay, from the other side, BE equals to BD plus DE. That is to say, BE equals to BD, that is 3 units, plus DE, that is 7 units. And 7 plus 3 is 10. So from the other side, BE equals to 10 units. So from this equation, 10 equals to BE equals to 2Y, we will conclude that 10 equals to 2Y. 10 equals to 2Y. Here we will divide this equation by 2 and we will get that Y equals to 5 units. So actually, Y, that is actually BM, is equal to 5 units, and Y, that is actually also equals to ME, is also equals to 5 units. So BM equals to 5 units and ME equals to 5 units. So you can write here that BM is equal to 5 units and ME is also equal to 5 units. Okay. In the next step, we will prove that triangle ABM congruent to triangle AME. I repeat, we will prove that triangle ABM, this triangle, congruent to triangle AME. So why those two triangles can go into each other? Triangle ABM and triangle AME. First of all, we know that AB is equal to AE. It is given us in the question. Okay, AB is equal to ME. It is given us the question. And we just right now found out that BM is equal to ME equals to 5 units. BM is equal to ME equals to 5 units. BM equals to ME equals to 5 units. And AM is a common side, it belongs to both triangles, so we can write down that AM equals to itself. AM equals to AM is a common side that belongs to both triangles. So we actually proved that the right triangle ABM, congruent, this is the sign of congruent, to the right triangle AME. According to side rule. We actually proved that all sides of triangle ABM can go into all the sides of triangle AME, therefore those two triangles can go into each other according to side rule. And from the fact that those two triangles can go into each other, we will conclude that angle BAM this angle BAM is equal to angle MAE. Angle MAE, that is actually this angle. Okay, angle BAM is equal to angle MAE. I'll repeat again. Angle BAM is equal to angle MAE according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other. Therefore, the corresponding angles, that is to say angle BAM and angle MAE, will be equal to each other. And if we define angle BAM as Z, if angle BAM is equal to Z. So I can write down here that angle BAM equals to Z. And from this equation, Z equals to angle BAM equals to angle MAE, we will conclude that angle MAE is also equals to Z. Okay? So we can write down here that angle MAE equals to Z, and angle BAM is also equals to Z. And what is the value of angle BAE? The value of angle BAE. The value of this big angle BAE. The value of angle BAE, from the drawing you can see that the value of angle BAE is equal to theta plus alpha. Again, angle BAE equals to theta plus alpha. Angle BAE equals to theta plus alpha from one side, but from the other side, angle BAE so from one side it equals to theta plus alpha, and from the other side, angle BAE equals to angle BAM plus angle MAE. It equals to angle BAM plus angle MAE. Okay? But angle BAM equals to Z, and angle MAE is also equals to Z. Z plus Z is 2Z. So from one side, angle BAE equals to theta plus alpha, and from the other side, angle BAE equals to 2Z. So from this equation, theta plus alpha equals to angle BAE equals to 2Z, we will conclude that theta plus alpha equals to 2Z. We'll divide this equation by 2 and we'll get that Z equals to theta plus alpha over 2. So actually, angle MAE is equal to Z. Angle MAE equals to Z, that is to say it equals to theta plus alpha over 2. And angle BAM is also equals to Z, that is to say it equals to theta plus alpha over 2. So you can write here that angle BAM, this angle equals to theta plus alpha over 2, and angle MAE is also equals to theta plus alpha over 2. Okay? In the next step, I will copy the right triangle AME in a new page, and we will analyze the right triangle MAE. Okay? We just right now found out that angle MAE is equal to theta plus alpha over 2. And from the drawing you can see that ME is equal to 5 units. So this is the right triangle AME. We will define AM as H. So AM is equal to H according to our definition. And what is the value of tangent theta plus alpha over 2? The value of tangent theta plus alpha over 2, it will be equal to ME over AM. But ME equals to 5 units and AM equals to H according to our definition. So in conclusion, we found out that according to equation number 1, tangent theta plus alpha over 2 is equal to 5 over H. According to equation number 1, tangent theta plus alpha over 2 equals to 5 over H. In the next step, I will copy the right triangle AMC in a new page, and we will analyze this right triangle AMC. According to our definition, AM is equal to H. And what is the value of angle MAC? The value of angle MAC will be equal to theta plus alpha over 2 plus theta. Okay, I'll repeat again. The value of angle MAC is equal to theta plus alpha over 2 plus alpha, and theta plus alpha over 2 plus theta. You can see it easily. Angle MAC equals to theta plus alpha over 2 plus theta. And what is the value of MC? The value of side MC is very easy to see from the drawing that MC is equal to ME plus EC. MC equals to ME plus EC, but we know that ME equals to 5 units and EC is the variable that we are looking for, it equals to X. So in conclusion, we found out that MC equals to 5 plus X. MC equals to 5 plus X, so we can write here that MC equals to 5 plus X. So this is the right triangle AMC. And we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, in triangle AMC, the sum of its angles must be equal to 180 degrees. So this angle that is angle MAC plus this angle that equals to 90 degrees plus this angle that is angle ACM, in total the sum of those three angles must be equal to 180 degrees. So I'll write it down. Angle MAC plus this angle that is 90 degrees plus angle ACM, that is the angle that we are looking for, angle ACM. In total the sum of those three angles must be equal to 180 degrees. Here we will subtract 90 degrees from this equation and we will get that angle MAC plus angle ACM are equal to 180 degrees minus 90 degrees, it is 90 degrees. So here we will subtract angle MAC from this equation and we will get that angle ACM, the angle that we are looking for, is equal to 90 degrees minus angle MAC. Okay. So angle ACM equals to 90 degrees minus angle MAC. What we know that (90 degrees) angle BAC equals to 90 degrees. Angle BAC equals to 90 degrees. From one side, but from the other side it equals to theta plus alpha plus 2 plus theta. From the other side it equals to 2 theta plus alpha. From this equation, 2 theta plus alpha equals to angle BAC equals to 90 degrees. We conclude that 2 theta plus alpha is equal to 90 degrees. That is to say, we can substitute 90 degrees in this equation by 2 theta plus alpha. So we will do it now. We will get that angle ACM equals to 2 theta plus alpha, that is 90 degrees, minus the value of angle MAC, and we already found out that the value of angle MAC equals to theta plus alpha over 2 plus theta. Here we will open the brackets and we will get that the value of angle ACM is equal to 2 theta plus alpha minus theta plus alpha over 2 minus theta. So angle ACM is equal to 2 theta minus theta is theta plus alpha minus theta plus alpha over 2. So we found out that angle ACM equals to theta plus alpha over 2 minus theta plus alpha. Angle ACM equals to theta plus alpha minus theta plus alpha over 2. And theta plus alpha minus theta plus alpha over 2 equals to theta plus alpha over 2. So we write down that the angle that we are looking for, that is actually angle ACM, equals to theta plus alpha over 2. So here I will draw again the right triangle, triangle ACM, and we will put the value that we found for angle ACM in this right triangle. So actually have the right triangle, triangle ACM. So this is the right triangle, triangle HCM, and we just right now found out that triangle HCM equals to theta plus alpha over 2. So what is the value of tangent theta plus alpha over 2? Here we will write down that the value of tangents theta plus alpha over 2, it is actually equals to AM over MC. But AM equals to H according to our definition, and MC, we already found out that MC equals to X plus 5, so in conclusion, we actually found out that according to equation number 2, tangents theta plus alpha over 2 is equal to H over X plus 5, and according to equation number 1, we have already found out that tangents theta plus alpha over 2 is equal to 5 over h. In the next step, we'll create equation number 3, that is the combination of equation number 1 with equation number 2. So according to equation number 3, tangent theta plus alpha over 2 it equals to a over x plus 5 according to equation number 2, while according to equation number 1, tangent theta plus alpha over 2 equals to 5 over h. Okay, this is equation number 3 again. I repeat that according to equation number 3, tangent theta plus alpha over 2 equals to h over 5 plus x, that is also equals to 5 over h. In the next step, we will find out the value of theta plus alpha over 2. What is the value of theta plus alpha over 2? The value of theta plus alpha over 2 it is actually equals to theta plus alpha, and we have already found out that alpha equals to 90 degrees minus 2 theta, so we'll substitute alpha by 90 degrees minus 2 theta, all divided by 2. Here we will open the brackets and we'll get that theta minus 2 theta plus 90 degrees over 2 equals to 90 degrees. Theta minus 2 theta is minus theta over 2. 90 degrees over 2 is 45 degrees minus theta over 2. So in conclusion, we actually found out that theta plus alpha over 2 is actually equals to 45 degrees minus theta over 2. And you already know that if alpha equals to beta, then tangent alpha will be equal to tangent beta. So according to the trigonometric identity that I mentioned, tangent theta plus alpha over 2 will be equal to tangent 45 degrees minus theta over 2. And we have a trigonometric identity for tangent x minus y. Actually, tangent x minus y is equal to tangent x minus tangent y over 1 plus tangent x times tangent y. So we use this trigonometric identity that states that tangent x minus y equals to tangent x minus tangent y over 1 plus tangent x times tangent y in order to find out the value of tangent 45 degrees minus theta over 2. According to this trigonometric identity, we will get that the value of tangent 45 degrees minus theta over 2 will be equal to tangent 45 degrees minus tangent theta over 2, all divided by 1 plus tangent 45 degrees times tangent theta over 2. And it will be equal to tangent 45 degrees is 1, so it is 1 minus tangent theta over 2 divided by 1 plus tangent 45 degrees is 1, so it is plus tangent theta over 2. So in conclusion, we actually found out that tangent theta plus alpha over 2 is actually equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. Okay? So actually the only thing that we need to do in order to find out the value of tangent alpha plus theta over 2 is to find out the value of tangent theta over 2. Okay, so what is the value of tangent theta over 2? We actually have a trigonometric identity for tangent theta over 2. According to the following trigonometric identity, the value of tangent theta over 2 is equal to sinus theta over 1 plus cosine theta. Okay? So we use this trigonometric identity in order to find out the value of tangent theta over 2. Because we know that sinus theta is equals to 1 over 3, so the only thing that is left to do is to find out the value of cosine theta, and then we'll put the data inside this trigonometric identity, and we'll find out the value of tangent theta over 2, and then we will put the value of tangent theta over 2 in this equation in order to find out the value of tangent alpha plus theta over 2. Okay, so we start with the trigonometric identity that states that sinus square theta plus cosine square theta is equal to 1. We subtract sinus square theta from this equation, and we will get that cosine square theta equals to 1 minus sine square theta. Here we take a root out of this equation, and we find out that cosine theta is equal to the square root of 1 minus sine square theta. We know that sinus theta is equal to 1 over 3, therefore sinus square theta will be equal to 1 over 9. And we'll put the value of sinus square theta inside the equation of cosine theta. So cosine theta is equal to the square root of 1 minus sine square theta that is 1 over 9, and 1 minus 1 over 9 is 8 over 9, so it is the square root of 8 over 9, and 8 is 4 times 2, and the square root of 4 times 2, the square root of 4 is 2, so it is 4 times square root, it is 2 times square root of 2. The square root of 8 is 2 times square root of 2, and the square root of 9 is 3. So in conclusion, we found out that cosine theta is equal to 2 times square root of 2 over 3. And we already found out that sine of theta equals to 1 over 3. Now we will put the values of sine theta and cosine theta in the trigonometric identity of tan theta over 2. So according to the trigonometric identity of tan theta over 2 is equal to sin theta, and sin theta is 1 over 3 over 1 plus cosine theta, and we just right now found out that cosine theta equals to 2 times square root of 2 over 3. So here we will multiply 1 by 3, and then we will divide it by 3 in order to have a common factor with this expression, and we will get that it equals to 1 over 3 over 3 plus 2 times square root of 2 over 3. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled, and we found out that tan theta over 2 equals to 1 over 3 plus 2 times square root of 2. I'll repeat again, tangent theta over 2 is equal to 1 over 3 plus 2 times square root of 2. So we take this expression and we will simplify it. So we have the expression of 1 over 3 plus 2 times square root of 2 So here we will multiply this expression by 3 minus 2 times square root of 2, and then we will divide it by 3 minus 2 times square root of 2. So in the numerator we have 3 minus 2 times square root of 2, and in the denominator we have expression that is very similar to a plus b times a minus b, that is equal to a square minus b square. Here a is 3, so a square is 3 square, 3 square is 9, minus b square. B is 2 times square root of 2, so b square is 2 times square root of 2 square, that is 8. So in conclusion, in the denominator we have 9 minus 8. So in conclusion, we found out that this expression equals to 3 minus 2 times square root of 2. Therefore, we actually found out that tangent theta over 2 is equal to 3 minus 2 times square root of 2. Okay? So now we will put the value of tangent theta over 2 inside the equation for tangent theta plus alpha over 2. We have already found out that tangent theta plus alpha over 2 is equal to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So it equals to 1 minus tangent theta over 2 is 3 minus 2 times root of 2 over 1 plus tangent theta over 2, it is actually equals to 3 minus 2 times root of 2. So here 1 minus 3 is minus 2, and minus is plus, so it is minus 2 plus 2 times root of 2 divided by 1 plus 3 is 4. Minus 2 times root of 2. So it equals to 2 times root of 2 minus 2 over 4 minus 2 times root of 2. Here we take 2 as a common factor from the numerator, and inside the brackets we will have square root of 2 minus 1 over, from the denominator we will take a common factor of 2 times square root of 2, and inside the brackets we will have square root of 2 minus 1. So here square root of 2, we have square root of 2 minus 1 in the numerator and square root of 2 minus 1 in the denominator, so square root of 2 minus 1 will get cancelled. We have 2 in the numerator, 2 in the denominator, so 2 will also get cancelled, and we left only with 1 over square root of 2. So we found out that the value of tangent theta plus alpha over 2 is equal to 1 over square root of 2. And we have already found out that according to equation number 3, the value of tangent theta plus alpha over 2, it is actually equals to h over x plus 5, that equals to 5 over h, and we just right now found out that tangent theta plus alpha over 2 is also equal to 1 over square root of 2. So from this long equation, equation number 3, we will derive that 5 over h equals to 1 over square root of 2. So we can write down that 5 over h is equal to 1 over square root of 2. Here we'll cross multiply this equation and we'll get that h equals to 5 times square root of 2. So we found out that h equals to 5 times square root of 2. And in the next step we will derive from this equation the equation that says that h over x plus 5 is equals to 1 over square root of 2. So I'll write it down. We have the equation that says that h over x plus 5 is equal to 1 over square root of 2. We have already found out that h equals to 5 times square root of 2. So we substitute h by 5 times square root of 2, or x plus 5 is equal to 1 over square root of 2. Here we will cross multiply this equation and we will get that five times square root of 2 times square root of 2 equals to x plus 5. So square root of 2 times square root of 2 is 2, and 2 times 5 is 10. So we found out that 10 equals to x plus 5. We subtract 5 from this equation and we get that x equals to 5 units. So the answer to the question is that x equals to 5 units, so x that is also equals to EC equals to 5 units. I will repeat again, the answer to the question is that x that is also equals to EC is equal to 5 units. Okay, in the next step I will summarize the lecture. Actually, we wanted to find out the value of line segment EC that equals to x, and we have here triangle ABC. We know that BD equals to 3 units, D equals to 7 units, AB equals to AE, angle BAC equals to 90 degrees, angle BAD equals to theta, and angle EAC is also equals to theta, and we want to find out the value of line segment EC that equals to x. So first of all, we defined angle DAE as alpha, and from point A we drew perpendicular to BC, and we defined the touching point of the perpendicular from point A to BC as M. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. Then we calculated the ratio between the area of triangle BAD and triangle AED. Okay, here the area of triangle ABD over the area of triangle AED. The square brackets is the sign for the area. So the area of triangle ABD is equals to BD times AM over 2, and the area of triangle AED is equal to DE times AM over 2. Here we have 2 with the numerator and 2 with the denominator, so 2 will get cancelled, and we left only with dB times AM over dE times AM. AM over AM is 1, so it will get cancelled, and we left only with dB over dE. dB is 3, dE is 7, so in conclusion we found out that the area of triangle ABD over the area of triangle AED is equals to 3 over 7. Then we calculated in another way the area of triangle ABD and the area of triangle AD. The area of triangle ABD was calculated in a different way. Actually, the area of triangle ABD equals to the base AB times the height to the base, that is edge 1 over 2. The area of triangle ABD equals to the base AB times the height to the base, that is edge 1 over 2. And the area of triangle AED was calculated in a different way. The base now is AE, the height to the base is H2 over 2. So the area of triangle AD equals to AE times H2 over 2. Here 2 over 2 is 1, so we left, so it will get cancelled, and we left only with AB times H1 over AE times H2. Now we have to find out the value of H1 and H2. Here in triangle, the right triangle ADO, sinus theta equals to H1 over AD. Sinus theta in the right triangle ADO equals to H1 over AD. We multiplied this equation by AD, and we found out that H1 equals to AD times sinus theta. Then, so we put the value of H1 here. edge 1 equals to AD times sinus theta. Then we focused on the right triangle ADK. In this triangle ADK, we know that sinus alpha equals to H2 over AD. Sinus alpha equals to H2 over AD. We multiplied this equation by AD. We found out that H2 equals to AD times sinus alpha. Here H2 equals to AD times sinus alpha. AD over AD is 1, so it will get cancelled. And we left only with 3 over 7 that equals to sinus theta over sinus alpha. Again, according to equation number 1, 3 over 7 is equal to sinus theta over sinus alpha. That's what is left after we cancelled all the other variables. Here we multiplied the equation number 1 and we found out that 3 times sinus alpha equals to 7 times sinus theta. We know that from one side angle BAC, the big angle equals to 90 degrees. From the other side angle BAC equals to 2 theta plus alpha. So from this equation 90 degrees equals to angle BAC equals to 2 theta plus alpha, we will conclude that 90 degrees equals to 2 theta plus alpha. We subtracted 2 theta from this equation and we found out that angle alpha equals to 90 degrees minus 2 theta. And because of the fact that angle alpha equals to 90 degrees minus 2 theta, we will substitute angle alpha by 90 degrees minus 2 theta. We did it and we got that 3 times sinus alpha and alpha equals to 90 degrees minus 2 theta equals to 7 times sinus theta. Then we use the trigonometric identity that states that sinus 90 degrees minus x equals to cosine x. And according to this trigonometric identity, we will get that sinus 90 degrees minus 2 theta equals to cosine 2 theta. Okay? And therefore we can substitute sinus 90 degrees minus 2 theta by cosine 2 theta. We did it and we got that 3 times cosine 2 theta equals to 7 times sinus theta. Okay? Then we have trigonometric identity for cosine 2 theta also. And the trigonometric identity for cosine 2 theta is 1 minus 2 sine squared theta. So according to this trigonometric identity, we can substitute cosine 2 theta by 1 minus 2 sine theta. We have the equation number 1 that states that 3 times cosine 2 theta equals to 7 times sine theta. So we'll substitute cosine 2 theta by 1 minus 2 sine squared theta. We did it and we got that 3 cosine 2 theta is 1 minus 2 sine squared theta, that equals to 7 times sine theta. We open the brackets here and we got that 3 times 1 is 3 and 3 times minus 2 sine squared theta is equals to minus 6 times sine squared theta, that equals to 7 times sine theta. So we added 6 times sine squared theta and we also subtracted 3 from this equation number 1, and we got the quadratic equation that says that 6 times sine squared theta plus 7 times sine theta minus 3 equals to 0. The general formula for quadratic equation is ax squared plus bx plus c equals to 0, and here the coefficient of the quadratic equation are a, b, and c, and x is the variable that we are looking for, and we find out the value of x according to the special formula for x, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the variable that we are looking for is sinus theta, so x equals to sinus theta. A, the variable a, the coefficient a equals to 6, the coefficient b equals to 7, and the coefficient c equals to minus 3. So we put the data inside the formula for x and we found out that sinus theta, x equals to sinus theta, therefore sinus theta equals to minus b, b equals to 7, so minus b is minus 7, plus minus square root of b squared minus 4 times ac over 2a. So b squared, b is 7, so b squared is 7 squared, 7 squared is 49. Minus 4 times AC. A is 6 and C is minus 3, so it is minus 4 times 6 is minus 24, minus 24 times minus 5, minus 24 times minus 3 is 72. So in conclusion, and divided by 2a, a is 6, so it is 2 times 6. And we found out that this expression equals to 72, so inside the root we have 49 plus 72 divided by 12. 49 plus 72 is 121, and the square root of 121 is 11. So we found out that sinus theta equals to minus 7 plus minus 11 over 12. So we have two solutions that are possible for sinus theta. The first solution for sinus theta is that sinus theta equals to minus 7 minus 11 over 12, and the second solution for sinus theta is that sinus theta equals to minus 7 plus 11 over 12. So we focus on the first solution. The first solution is minus 7 minus 11 over 12. This is the value of sinus theta. Minus 7 minus 11 is minus 18, and minus 18 over 12 is minus 1.5. So we found out that sinus theta equals to 1.5. But it is impossible that sinus theta will be equal to minus 1.5 because the range of values that sinus theta can accept is the values that are ranging from minus 1 to plus 1. And because of the fact that minus 1.5 is less than minus y, minus 1.5 is less than minus 1, that is to say it exceeds from the range of the values that sinus theta can accept. Therefore, it is incorrect answer. So we cancel this answer and we left only with the answer that sinus theta equals to minus 7 plus 11 over 12. Minus 7 plus 11 is 4, so 4 over 12. 4, we divided both the numerator and the denominator by 4. 4 over 4 is 1, and 12 over 4 is 3. So in conclusion, we found out that sinus theta equals to 1 over 3. Okay? Then we focused on the right triangle ABE. We focused on the isosceles triangle ABE. Why triangle ABE is an isosceles triangle? Because of the fact that AB equals to AE. Therefore, it is an isosceles triangle. From point A, we have perpendicular to BE. That is to say, the perpendicular AM to the base, and the base is BE. So the perpendicular to the base AM, it is actually the height to the base BE. So line segment AM is the height to the base BE. Okay? And BE is of course the base. And line segment AM is the height to the base BE. Okay? And we have rule number 1. According to rule number 1, the height to the base of an isosceles triangle bisects the base. So according to rule number 1, the height AM bisects the base BE. That is to say, BM is equal to ME. So BM is equal to ME according to rule number 1. And if we define BM as Y, then from this equation, we will derive that ME is also equals to Y. Okay, so we actually have, we know that BM equals to Y and ME equals to Y. And what is the value of BE? You can see it easily from the drawing that BE equals to BM plus ME from one side. BE equals to BM plus ME from one side, but BM equals to Y and ME is also equals to Y. So in conclusion, BE equals to Y plus Y, that is 2Y. So from one side, BE equals to 2Y. But from the other side, what is the value of BE? The value of BE is BD plus DE. That is to say, the value of BE, that it is BD that is 3 plus DE that is 7. So in conclusion, BE equals to 3 plus 7, that is 10 units. So in the other side, BE equals to 10 units. So from one side it equals to 2y, from the other side BE equals to 10 units. So from this equation, we will derive that 10 equals to 2y. We will divide this equation by 2 and we will get that y equals to 5 units. Y, that is BM, equals to 5 units, so BM equals to 5 units, and ME, that is also Y, is equals to 5 units. That is to say, ME is also equal to 5 units. So we can write down here that BM equals to 5 units and ME is also equals to 5 units. Then we proved that those two right triangles can go into each other. That is to say, the triangle ABM can go into triangle AME. Why those two triangles can go into each other? First of all, we know that AB is equal to AB. It is given us in the question. And we just right now proved that BM equals to ME equals to 5 units, and AM equals to itself. AM is a common side that belongs to both triangles, so AM equals to AM. It's a common side that belongs to both triangles, so we proved that triangle ABM can go into triangle AME according to side rule. From the fact that those two triangles can go into each other, we will conclude that angle BAM is equal to angle MAE. According to the rule that corresponding angles in congruent triangles are equal to each other. Okay, angle BAM equals to angle MAE. So if we define angle BAM as Z, then angle MAE will be also equal to Z. Then so we know that angle MAE equals to Z, and angle BAM is also equal to Z. And from the drawing, it is very easy to see that the value of angle BAE, it is actually equals to theta plus alpha. The value of angle BAE equals to theta plus alpha, but from the other side, the value of angle BAE is equal to angle BAM plus angle MAE. The value of angle BAM from the other side equals to angle BAM plus angle MAE. Angle BAM is Z and angle MAE is Z. So angle BAE equals to Z plus Z, that is to say 2Z. So from one side, angle BAE equals to theta plus alpha, and from the other side, it equals to 2Z. From this equation, we will derive that theta plus alpha equals to 2Z. We divided this equation by 2, and we got that angle Z equals to theta plus alpha over 2. That is to say, angle MAE that equals to Z, it equals to theta plus alpha over 2, and angle BAM that is also equals to Z, it equals to theta plus alpha over 2. So we can write here that angle BAM equals to theta plus alpha over 2, and angle MAE is also equals to theta plus alpha over 2. Then I copied the right triangle, triangle MAE in a new page, and we analyzed the right triangle, triangle MAE. This is the right triangle, triangle MAE. We just right now found out that angle MAE equals to theta plus alpha over 2. AM is equal to H according to our definition. ME, what is the value of ME? You can see from the drawing that ME equals to 5 units. So here, in the right triangle, triangle MAE times theta plus alpha over 2 will be equal to ME over AM. ME over AM. ME equals to 5 units. AM equals to H. So in conclusion, we found out that according to equation number 1, triangle theta plus alpha over 2 equals to 5 over H. Then we focused on the right triangle, triangle AMC, so I copied it in a new page and we analyzed the right triangle, triangle AMC. We have the right triangle, triangle AMC. AM equals to H according to our definition. What is the value of angle MAC? The value of angle MAC, it is actually equals to theta plus alpha over 2 plus theta. It is very easy to see that the value of angle MAC is equal to theta plus alpha over 2 plus theta. Here, the value of angle MAC equals to theta plus alpha over 2 plus theta. And what is the value of MC? It is very easy to see from the drawing that MC equals to ME plus EC. Okay, MC equals to ME plus EC. Here, MC equals to ME plus EC. But ME equals to 5 units. EC equals to X, so in conclusion, we found out that MC equals to 5 plus X. Okay, so, and we know that the sum of the angles in any triangle is equal to 180 degrees. And especially in triangle AMC, so angle MAC plus 90 degrees plus angle ACM, in total they must be equal to 180 degrees. Angle MAC plus 90 degrees plus angle ACM equals to 180 degrees. We subtracted 90 degrees from this equation and we got that angle MAC plus angle MCA equals to 90 degrees. Then we subtracted angle MAC from this equation and we found out that angle ACM equals to 90 degrees minus angle MAC. But 90 degrees is actually 2 theta plus alpha, so we substituted 90 degrees by 2 theta plus alpha, and we got that angle ACM equals to 2 theta plus alpha minus angle MAC. What is the value of angle MAC? It equals to theta plus alpha over 2 plus theta. Theta plus alpha over 2 plus theta. We open the brackets here, and we got that angle MAC equals to 2 theta plus alpha minus theta plus alpha over 2, and we have minus before the bracket, so the plus sign will become minus here. It is minus theta. 2 theta minus theta is theta, so we have here theta plus alpha minus theta plus alpha over 2. And theta plus alpha minus theta plus alpha over 2 is theta plus alpha over 2. So we actually found out that angle, this angle that we are looking for, angle ACM, equals to theta plus alpha over 2. MC equals to X plus 5, AM equals to H. So here, times theta plus alpha over 2 will be equal to AM over MC. Okay? Times theta plus alpha over 2 equals to AM over MC. AM equals to H. MC equals to X plus 5. So in conclusion, we found out that according to equation number 2, times theta plus alpha over 2 equals to H over X plus 5. And according to equation number 1, we have already found out that times theta plus alpha over 2 equals to 5 over H. Then we created equation number 3, that is the combination of equation number 1 with equation number 2. That is to say, according to equation number 3, times theta plus alpha over 2 equals to H over 5 plus X according to equation number 2, while according to equation number 1, times theta plus alpha over 2 equals to 5 over H. Okay, then we found out the value of theta plus alpha over 2. Theta plus alpha over 2 equals to theta, and alpha equals to 90 degrees minus 2 theta, so we subtracted alpha by 90 degrees minus 2 theta, and we got that theta plus 90 degrees minus 2 theta over 2 equals to, we open the brackets here, so it is theta minus 2 theta plus 90 degrees over 2, so we have 90 degrees minus 2 theta minus 2 theta is minus theta over 2. 90 degrees over 2 is 45 degrees minus theta over 2. So in conclusion, we found out that theta plus alpha over 2 equals to 45 degrees minus theta over 2. And we know that if alpha equals to beta, then tangent alpha equals to tangent beta. Therefore, tangent theta plus alpha over 2 will be equal to tangent 45 degrees minus theta over 2. And we have the trigonometric identity that tangent x minus y equals to tangent x minus tangent y over 1 plus tangent x times tangent y. According to this trigonometric identity, we will get that the value of tangent 45 degrees minus theta over 2 equals to tangent 45 degrees minus tangent theta over 2 over 1 plus tangent 45 degrees times tangent theta over 2. We know that tangent 45 degrees is equal to 1, so it is 1 minus tangent theta over 2 over 1 plus tangent 45 degrees is 1, so it is 1 plus tangent theta over 2. So in conclusion, we found out that tangent theta plus alpha over 2 equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So the only thing that is left to do in order to find out the value of tangent theta plus alpha over 2 is to find out the value of tangent theta over 2. And we have trigonometric identity for tangent theta over 2. Actually, the trigonometric identity for tangent theta over 2 is that tangent theta over 2 equals to sinus alpha over 1 plus cosine. Tangent theta over 2 equals to sinus theta over 1 plus cosine theta. And we already found out that sinus theta equals to 1 over 3, and we have the trigonometric identity that states that sinus square theta plus cosine square theta equals to 1. We subtracted sinus square theta from this trigonometric identity, and we got that cosine square theta equals to 1 minus sine square theta. We took a root of this trigonometric identity, and we got that cosine theta equals to the square root of 1 minus sinus square theta. And because of the fact that sinus theta equals to 1 over 3, sinus square theta will be equal to 1 over 9. So we can substitute sinus square theta in this trigonometric identity by 1 over 9. We did it, and we got that cosine theta equals to the square root of 1 minus 1 over 9. 1 minus 1 over 9 is 8 over 9. And the square root of 8 is 2 times square root of 2, the square root of 9 is 3, so in conclusion we found out that cosine theta equals to 2 times square root of 2 over 3, and we already found out that sine theta equals to 1 over 3. So now we can put the values of cosine theta and sine theta inside the trigonometric identity in order to find out the value of tangent theta over 2. So the value of tangent theta over 2 according to this trigonometric identity will be equal to sinus theta, that is 1 over 3, over 1 plus cosine theta, that is 2 times square root of 2 over 3. Here we have 3 in the numerator and 3 in the... No, well, first of all we multiplied 1 by 3, then we divided by 3 in order to have a common factor with this expression, and we got that 1 over 3 over 3 plus 2 times square root of 2 over 3. We have 3 in the numerator and 3 in the denominator, so 3 will get cancelled, and we're left only with 1 over 3 plus 2 times square root of 2. So in conclusion, we found out that tangent theta over 2 equals to 1 over 3 plus 2 times square root of 2. Then we simplified this expression. So we have the expression of 1 over 3 plus 2 times square root of 2. We multiplied by 3 minus 2 times square root of 2, and we divide it by 3 minus 2 times square root of 2. So in the numerator we have 3 minus 2 times square root of 2, and in the denominator we have expression that is very similar to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. Here a equals to 3, so a squared is 3 squared, 3 squared is 9. B equals 2 times square root of 2, so b squared is 2 times square root of 2 squared, that is 8. So in conclusion, in the denominator we have a squared minus b squared, that is 9 minus 8. And in the denominator we have 3 minus 2 times square root of 2, and 1, everything that is divided by 1, it will be equal to, it will not change anything, so 3 minus, so we found out that this expression equals to 3 minus 2 times square root of 2. Tangent theta over 2 equals to 3 minus 2 times square root of 2. Okay? So here we can put the value of tangent theta over 2 inside the equation of tangent theta plus alpha over 2 that states that it equals to 1 plus tangent theta over 2 over 1 plus 1 minus tangent theta over 2 over 1 plus tangent theta over 2. Here we have 1 minus tangent theta over 2 is 3 minus 2 times square root of 2. And we have here over 1 plus tangent theta over 2, that is 3 minus 2 times square root of 2. And here 1 minus 3 is minus 2, minus and minus is plus, so in the numerator we have minus 2 plus 2 times square root of 2, 1 plus 3 is 4, so in the denominator we have 4 minus 2 times square root of 2, so we have here minus 2 times square root of 2 2 times square root of 2 minus 2 over 4 minus 2 times square root of 2. Here, from the numerator we took 2 as a common factor, and inside the brackets we have square root of 2 minus 1, and from the denominator we took 2 times square root of 2 as a common factor, and inside the brackets we have square root of 2 minus 1. Square root of 2 minus 1 over square root of 2 minus 1 will get cancelled, and 2 over 2 will also get cancelled, and we left only with 1 over square root of 2. So in conclusion, we found out that tangent theta plus alpha over 2 equals to 1 over square root of 2. So we can write down equation number 3, and we can add to equation number 3 that tangent theta plus alpha over 2 equals to 1 over square root of 2. That's what is just found out right now. Then we derived this equation from the normal equation of equation number 3, that 5 over h equals to 1 over square root of 2. That is to say, 5 over h equals to 1 over square root of 2, because multiply this equation and we got that h equals to 5 times square root of 2. H equals to 5 times square root of 2. Then we derive the second equation for this equation number 3, that h over x plus 5 equals to 1 over square root of 2. Here, h over x plus 5 equals to 1 over square root of 2. We know that h equals to 5 times square root of 2, so we substituted h by 5 times square root of 2, and we got that 5 times square root of 2 over x plus 5 equals to 1 over square root of 2. We cross multiplied this equation, and we found out that 5 times square root of 2 times square root of 2 equals to x plus 5. Square root of 2 times square root of 2 is 2, and 2 times 5 is 10. So in conclusion, we found out that 10 equals to x plus 5. We subtracted 5 from this equation, and we got that x equals to 5 units. So x that equals to CE is actually equals to 5 units. So we actually found out that the value of line segment EC that equals to x is equal to 5 units. Okay, so the answer to the question is that x that equals to EC equals to 5 units. Okay, thank you very much.